Okay, so let's take a look at the first task for today, and before we do that, we have an overall general route plan description. And can everyone see my screen and everything looks fine? Make sure that nothing's cut off. Also note that you do have a full screen option. Okay, great. So route plan description and overall guidelines. We're told that phones at the CUCME Netherlands location use a prefix code of 0 to access a PSTN trunk. Outside dial tones should be provided as soon as the PSTN trunk code has been dialed. Branch 2 CUCME is located in the Netherlands, has a country code of 31. Branch 2 is in the city of Amsterdam. Users should be able to dial 112 from that branch 2 location to reach emergency services. Make sure the PSTN trunk code of 0 for the Netherlands are each stripped before each call goes out to the PSTN. Local area code, and by the way, that would seem to imply that dialing 112 is a necessary PSTN pattern, and then also from the first bullet point, that it would seem to imply, and you could, if this were a real lab, ask the proctor, or you could simply just go ahead and create it, since it wouldn't take that much additional time and certainly save you losing any points if you didn't. But it would seem to imply that you need not only 112, but also 0112. Just like if we were in the US, not only 911, but also 9911. Okay, local area subscriber PSTN calls are placed from branch 2 by dialing 7-digit numbers. Long distance, also known as national PSTN calls, are placed from branch 2 by dialing 10-digit numbers, with the first number being the national access code of 0. This is in addition to the PSTN trunk code of 0. So if we're dialing nationally, we'll dial 00. International calls should be prefixed with 00, along with country code and variable length trunk number, or not trunk number, but variable length number for the site and number you're trying to reach. This is in addition to the PSTN trunk code of 0. So it would be 000 if we're dialing internationally. You should allow for any phones to be able to terminate interdigit timeout on an international number using the hash key or pound or octathorpe, depending on what you call it, in order to place the call immediately. So let's take a look at 16.1 PSTN dialing in CUCME. We're told to configure the CUCME router to allow SIP and skinny IP phones to place calls out of the PSTN using the table or information from the table, which is numbered incorrectly. I'll change that before you guys download it. It should be table 16.1. The connection that the PSTN is providing to the branch 2 site is ISDN PRI Euro, framing is CRC4, line code is HDB3, and the PSTN only has the first 3 channels of the PRI lit up. Sorry for the scroll. My mouse, let me just get it here right. Great on just about everything else, but for some reason when I'm highlighting things, it doesn't really have a physical mouse button. It's just that trackpad. So anyway, ensure that the PSTN sees CNAM, or calling name display, for calls outbound from branch 2. Ensure that any calls made to international numbers only have to wait 7 digits after the last digit to route to the PSTN. And as we mentioned again, users have the option of pressing the hash pound octathorpe key to route the call immediately. So we see that we've got emergency numbers 112. Local are defined as the first digit, can be anything 1 through 8, and then 6 additional digits. We see that a class of restriction, when we get there, although we're not yet, will be defined as local. We weren't instructed to do anything with class of restriction yet. National, or also known as long distance calling, begins with a 0, and again this is in addition to the 0 trunk code. Then a 1 through 8, XX, and then 7 digits. So it looks like a total of 1, 2, 3, 4, 1, 2, 3, 4, and then 1, so 9 digits plus the leading 0 for the geographic code or area code, so a total of 10 digits plus the 0 PSTN trunk code. So 0 and then 10 digits. International, 00, and variable length with the class of restriction international. Okay, So let's take a look at our branch 2, router 3, CUCME router. And let's just look real briefly at what we had already from the last module. And do note that from module to module, some things change. So in other words, if we did something at the during the configuration of module 15, if you just got done watching that or have already previously watched it, and so that was part of the final configuration for module 15, I may have changed one or two things before the module here for the startup configurations for module 16. So for instance, we were registering all of our numbers to a SIP proxy server at the end of module 15. I've taken out the SIP UA registrar server command here in the startup configs for module 16 because, or at least I believe I have in this startup config, it will be by the time you download the configs, because we don't want that constantly trying to register those numbers. It wasn't a real SIP proxy server, or at least not a fully configured one, as we mentioned. We were just demonstrating something. So some things will change from the final of one to the startup of the next. So don't necessarily assume that. Always load the startup configs. Okay, so we've got things like clock time zone set and summertime. We've got our DHCP pools. In fact, we can do a show IP DHCP bindings. We've got 3 phones, should be 4 phones, but one phone is having a little bit of a hard time registering for some reason. One of my SIP phones that was previously working just fine. Got an IP address here. It does have an IP address. Oh, it looks like possibly we have a, no, I don't think so. Lease and renew of these. 1 second, because they keep trying to register. Okay, well, I'll take a look at that on a break. We should have 4 phones registered. We had 3 in the last module. I've added 1 more since then. And we bring up our switch 2. In fact, let me also very briefly bring up our diagram for this module, just in case you haven't looked at module 15. Actually, for this module, here we've got our branch 2 site. And on this branch 2 site, we see it's really the only one we're looking at today. We will have a link back to the corporate headquarters in branch 1 where there's 1 phone. But in today's module, we're actually going to have, maybe I should have used a different color. In today's module, we're actually going to have 4 phones. So we're going to have DN skinny phone with a DN of 3001, another skinny phone with a DN of 3002, a SIP phone with a DN of 3003, and a SIP phone with the DN of 3004. Okay, I'll actually change that diagram to be a little bit more accurate and include that as the as the diagram for the downloadable files. Okay, looks like all the phones are registered now. So hopefully they'll stay that way. All right, so if we do a show CDP neighbor, we note that we do have all 4 phones. They all look like they're connected to one port. As we've mentioned before, this is because we're doing layer 2 tunneling. The phones are in front of me. The rack equipment is not. They're not physically connected, but they certainly look like they're connected. And this is how, if you're studying for the CCI Voice Lab, this is how your phones will be connected regardless of whether you sit at San Jose, RTP, Bangalore. All of the phones are physically, all of the lab equipment is physically back at San Jose, but even if you're sitting at San Jose, there is a layer 2 trunk up to the equipment room, and your phones are not directly connected. So if you just shut down a port, that will not disconnect power. Okay. So there's our 4 phones. For some reason, we're only showing 3 IP bindings. This is probably because, and I think this is what keeps causing 2 of them to mess up a little bit. I didn't save my DHCP config after doing some testing, and then, whoops, didn't really mean to exit, and then reloading the router. So let me get out of this console session where we don't have very fast access, get into a telnet session, and look at the configuration. Okay, so we've got our DHCP, we've got our voice service VoIP allow connection SIP to SIP, and a redirect server. So we've got a SIP registrar server, we've got a redirect server. We're essentially a proxy server as well. We've got our voice class codec, which you'll see here is applied to our voice register pool 1 and 2. So we've got the fact that our preference is G711A law as number 1 and G729 as number 2. In module 15, we demonstrated how it can negotiate between those two. We've got our voice register global in mode CME, our max DNs and pools, our load files, time format, create profile, which we mentioned anytime we change anything in SIP, voice register global, or DN, or template or pool, we have to go do a no create profile, and then go and reload both of these. And we also said that it was for that reason that, and let me pull up the text edit or notepad that we use. Something I said would be a good idea to create in the lab. You don't have to put spaces, but I'm just doing it so that we have some separation. Okay, it would be a good idea to create this little file that just a notepad file that contains voice register global, no create, voice register pool 1 restart, pool 2 restart, depending on however many phones you have, whether they're SIP or skinny. And then even just because of some issues that can occur that we noted in module 15, might not be a bad idea to do a telephony service, no create, and ePhones restart. So we'll just copy the whole thing and paste it anytime we have any changes that need to be applied. Okay, so we've now got one additional SIP phone from module 15. We had 1 SIP phone and 2 skinny in last. Now we've got 2 SIP and 2 skinny. So we've got voice register DN1 with number 3000 for James Ford, and DN2 with number 3004 for Hugo Reyes. Okay, we've got the 2 voice register pools. Everything's good there. And then we've got all of our TFTP servings, including ringtones and desktop backgrounds that we looked at in 15. 1 dial peer to call manager that we'll be adding on to today. Our general telephony service for our skinny server, ePhone DN templates, ePhone templates, and then 2 ePhone DNs for 3001 Desmond Hume, 3002 John Locke, and then the 2 ePhones that they are applied to. Okay, so that's our basic config so far, and also NTP. Let's see if that's synced up. Show NTP association. We are synced with the PSTN. We can see with the asterisks. Okay, so let's clear this off. and let's begin our configuration. So the first thing we have to do is set up an ISDN switch type, and we'll set it up to primary PRI, and we're going to choose net 5. Net 5 being the switch type for UK, Europe, Asia, and Australia, also known as PRI Euro. Okay, now we're going to jump into our first controller, 000, and if we did show run pipe 2 section controller, we would see that we have 2. One's already set up with a channel group, so a data slot, and one says it's our voice circuit, but it doesn't have any configuration in it, so that's the one we'll use. We're going to set up a PRI group with time slots 1 through 3, and we're not going to add any service. We're certainly not doing NFAS. Okay, so we've created our PRI group. Now that automatically created an interface for serial 000:23, or the D channel. Sorry, :15. This is an E1. And it also created a show run pipe 2 include voice port. It also created our voice port for us. Okay, so now we're going to jump into the D channel, and we're going to specifically say ISDN outgoing display IE, since we were told to have CNAM support. Okay, so we've configured that. Now we need to set up some of our dial peers. So we'll set up dial peer voice 1 for POTS, not ports, but POTS, plain old telephony service. We also have, of course, PANs, our pretty advanced new stuff. And we'll set up our destination pattern. And there's too much ambiguity, so sometimes it's helpful to type things out versus just hitting tab. Destination pattern, and we're going to start it out with $112, $, caret being a regular expression that indicates the beginning of a literal string, and a $, indicating the end of a string or a literal string. Okay, then we're going to add a, you know what, we're actually going to make this a dual purpose dial peer. Again, it's sometimes useful to have dial peers that are inbound separate from your outbound dial peers, just for sake of sanity and configuration, not configuration, but rather troubleshooting and going back and looking at them later. And we've shown that in previous deep dives. Today we're actually going to put them into one dial peer, and the reason is just so that we can show how we can save configuration space. And again, might not be a bad idea to separate them for clarity and for the sake of confusion, but it's also no technical problems whatsoever to put them together. So we're also going to say the port 000:15, so we're doing the outbound portion first. And we have to state do show run pipe 2 begin dial dash peer. Actually, let's just do section voice 1. Show us 10 as well. There we go. All right, so we've got our destination pattern 112. Again, any explicitly matched digits, like 112, will be stripped by default. Okay? So we can do a number of different things here. We could say forward digits, all. We could say forward digits 3, since we want all 3 to go out to the PSTN. Or we could even say something such as no digit strip. Okay? Let's try this, no digit strip. Now, let's also do show ISDN status. Looks like our controller is up, multiple frames established. let's go ahead and place a call out to the PSTN and just test this. Hopefully these won't have too much delay in loading. If they do, then during a break I'll have to fire up an alternate means. It's just that when I've run Fusion, since I'm running a Mac and I have to have Windows to run these clients, when I've run Fusion in the past, if you've watched any of my previous deep dives, sometimes it'll lock up and I'll have to take a little bit of time to reboot my entire Fusion box because it'll lock up just because of the high CPU. Okay. So let's place a call out to, and actually, before we do that, let's go back and do debug ISDN Q931. Okay, do show deb. We've got just that debug running. All right. So let's place a call to 112. Oops, and I dialed it wrong. And let me actually change this. To refresh every 2 seconds rather. Might simply prove to be too slow, and I'll have to change my control method. Right now I'm using it over RDP to the XP machine. It does look like it's going to be too slow. All right, so after this first task, and we take a break for the second task, I'll switch over to another method where it's not going to be near as slow for the refresh. And of course, the reason we don't use IP-Blue soft clients, but rather we use an actual remote control client, which we're in negotiations with a new company that has a web-based one that would work on any platform and is really fast, that I'm quite excited about. But the reason that we use this instead of a soft client is because even the IP-Blue 7961 or 7962 type actually, it registers as that type, but it actually acts like a 7960, and so there's a lot of things that it doesn't do properly. So anyway, let's place the call out to 112. And we see that the call goes out. We can see that 112 was sent. So no digit strip worked just fine. Okay. Let's see, as we go on, what else we can do. All right. Now, let's go ahead and add our next dial peer. Oh, sorry. First, we wanted to do the, we mentioned make this also an inbound dial peer. So let's say incoming called number dot. And again, we wouldn't have to have the port if we were isolating this out. And we're also going to say, so this is going to match all inbound calls into the router where the type of call is a POTS call, unless there's a more specific match. And we're going to say direct inward dial so that the router doesn't terminate the call and provide dial tone where someone can dial again, but it actually passes the digits onto the outbound dial peers for digit analysis. Okay, so now let's say dial peer voice to POTS, and we want to say a destination pattern of caret 0112 $. Okay, so the destination pattern of 0 being the trunk code and then 112 being emergency, port 000:15, and this time we can't say no digit strip or 4 digits all. We have to specifically or explicitly Note that we only want 3 to go out to the PSTN because this is just a secondary dial tone trunk access code. Okay, now we're going to have our next dial peer 3 POTS, and we're going to do a destination pattern of caret to begin with 0, left bracket 1 through 8, excluding 9 and 0 as being a second digit, and then 1, 2, 3, 4, 5, 6 $sign. And we were instructed to do this per our table 16.1 here. And then we also have the same port, and then the amount of digits we want to forward, which for this particular task, we're going to want to forward 7 digits. Okay? So next dial peer, 4 POTS, and we're going to use our destination pattern. We'll just copy this of 00, 1 through 8. Let's see what we instructed. 00, 1 through 8, and then after that 1, 2, 3, 4, 1, 2, 3, 4, so 8 additional digits. So here we have 1, 2, 3, 4, 5, 6. We need to add 2 more dots there. Same port, and forward digits will be 10. That's how many the PSTN wants. The 11th digit being our trunk code. And then dial peer 5 with the destination pattern being, we can begin with 0. Actually, it's 000, so 0 for the secondary dial tone, and then 2 zeros for our international prefix we were instructed, and then T for timeout. Now, there's something special that happens when we add a T for timeout, or interdigit timeout, and when we use the caret. Okay, we're going to see a problem here. So we're going to want the port 000:15, and we're going to want to use a prefix of 00. Okay, we don't know how many digits will be dialed because depending on what country, what city, where we're dialing to, it could be different. Variable length. So we don't know how many digits to forward. We know that the first digit is just for our own sake of secondary dial tone or PSTN trunk code. We don't want that going out to the PSTN because they are not able to route or expecting 3 zeros as a prefix. They're expecting 2 zeros to indicate international dialing, and then the country code or numbering plan code. Okay, so prefix 00 is what we'll use since these 3 zeros will be stripped automatically because they're explicitly matched, and we're going to want to prefix back on 2 zeros that the PSTN is expecting. So let's take a look at our dial peers. We'll look at this one later. But here we've got, in fact, let's actually take this one out. We'll add this one back in a little bit. Just the only reason I'm taking it out is so that it will be ordered properly in just a little bit. So here we've got our dial peer 1, inbound and outbound. Outbound for 112 emergency, inbound for all POTS dial peers coming in from the PSTN. Dial peer 2, 0 trunk code plus emergency. Dial peer 3 is our local, forward digits 7. Dial peer 4 is our national, forward digits 10. Dial peer 5 is our international, prefix 00. Let's go ahead and test some of these. Clear the scroll back buffer in the screen and switch over to our phone. So let's dial 0112. That goes out and we can hear it ringing. I don't have a display of the PSTN phone just at the moment. We'll have it after the break. And then let's try dialing local. So let's dial 0, which we don't hear secondary dial tone yet. Let's fix that real quick so that we can test and hear that. So I was dialing from a skinny phone. I can't show you the SIP phones because the AXL doesn't control them, unfortunately. So let's go into telephony service and say secondary dial tone is going to be a word, a digit string, just 0. Okay, so now my skinny phones hear the secondary dial tone. I'll do that again. Okay, we hear the secondary dial tone. Dialed the wrong number. So 0, and then 703-7333, and it's ringing out to the PSTN, and I do see from Desmond Hume at 3001. So the calling name display is working properly as well. Okay, and we can also see it in the display IE. Good that we can see it in the display IE for Q931 debug. Better that we can actually, or getting the points in the lab, that we can actually see it on the PSTN or called phone, whomever that might be. Okay, so now let's call our national number 0010-704-7444. All right, that's calling out to the PSTN. We dialed 00, 1 for the secondary dial tone, but we only forwarded 10 digits. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. Okay? Now let's try our international number. Okay, we'll try again. Let's try it from John Locke's phone. Just using the other phone already. Not quite as loud. All right, so 000. First one did have secondary dial tone. 000, and then let's call 1-206-501-5111, which is PSTN line 1. Now, first of all, we had to wait for interdigit timeout because we haven't done anything. It shows unknown number. Let's go look at the debug. What happened here? Here's our 1-206-501-5111, and we needed 00 to be sent out, but we show 5 zeros. Now, wait a minute. Our dial peer do show run pipe 2 section voice. That was dial peer 5, I believe. Our dial peer had 3 zeros and then variable digits, and we see those 3 zeros. But then it also had prefix 00. Now wait a minute. I thought that it explicitly stripped anything that it stripped anything that was explicitly matched. I thought we just talked about that. And in fact, I think we saw that when we looked at dial peer 1, where we said no digit strip. In fact, let's just jump back into dial peer 1, and let's just go back to the default, which is digit strip. Now let's look at that dial peer again. Here's the way it was with no digit strip. Here's the way it is now. Digit strip doesn't show up because it is the default. We could do show dial peer 1 pipe to include digit strip, and we'd see that it's the default. It's turned on. So now it should be stripping these digits and should not send anything out to the PSTN, right? Well, let's try it. I won't even switch over to the display. I'll just dial it here. 112. Okay, it looks like it sent those digits. It didn't strip anything. So the default of digit strip did not work. It did not strip them. So here is the anomaly. We're in dial peer 1, right? The destination pattern we said was caret 112. Anytime we have a caret turned on to indicate the beginning of the string, it will not strip any digits. The default of digit strip is ignored. A little known fact in iOS. Anytime we have a caret, the default of digit strip is ignored. So now I changed it without the caret. It's just destination pattern 112. Digit strip doesn't show up in the no format, so it is enabled. Let's try that call again. I'll just hit redial. And I didn't even get reorder tone. It just literally just disappeared from my screen. But we do see the called party is set to the type, just like the calling party is set to the hex information element. But the calling number is here. The called number is non-existent because digit strip did its job and stripped the digits. So again, all I have to do is change this to a caret and then hit redial. And as long as I have the caret before a destination pattern, digit strip will not matter whether it's configured, whether it's left to the default, which is do strip explicitly match digits, or change to no digit strip. It effectively creates a no digit strip situation. Okay? Okay. So, you might ask, what about dial peer voice not 2? Well, yeah, what about dial peer voice 2? If it doesn't strip this digit, in other words, regardless of whether we have digit strip or no digit strip configured, it effectively is no digit strip when we have the caret. If we didn't strip this leading 0, then how did it go out with only 3 digits? Forward digits still works properly because forward digits is a hard number saying this is the number of digits from the right most significant to the left least significant number that you want the number of digits to be forwarded out, period. Doesn't have anything to do with digit strip or not. So that number worked just fine if I dial 0112. Okay? It has nothing to do with digit strip functionality. It just has to do with the hard, explicit number of digits I told it to forward out. Okay? Now what about, so that takes care of explaining 3, where we told it to forward explicitly 7 digits, and dial peer 4, where we told it to explicitly forward 10 digits. But what about dial peer 5, where we didn't tell it explicitly to forward any digits? This was where we got into trouble if I dial a 000 1206 501 5111. Wait for the interdigit timeout, which will change here in just a moment. And the problem is we see not only the 3 digits that we had, but also 2 more. So we prefixed 2 zeros to the existing 3 zeros. Why? Because we were counting on these zeros being stripped. We were counting on them being stripped. By what? By digit strip. And in fact, having digit strip work is the only way to make this particular dial peer work. So what we do have to do for this dial peer is change the destination pattern to not include a prefix caret. We can have it on all the rest. We know how to mitigate the anomaly, I should say, or exception of digit strip not working. But for this dial peer, show command, for this dial peer, we cannot have the caret, otherwise digit strip does not take effect, it doesn't strip these 3 zeros, and we can't prefix the 2 that we need. You could say, well, couldn't you just forward 2? No, that would only forward those 2. Actually, it would forward the last 2 digits, whatever they were, so 11 in this case. Could you, let's see, not prefix anything? No, but then it sends 3 zeros out, and the PSTN won't route it. This is pretty much the only way to do it. So let's try the redial again. Wait for the interdigit timeout. Waiting, waiting, waiting. I hit redial already. There we go. Now digit strip those 3 zeros and prefix the 2, and the call is routing out to the PSTN properly. Okay? Let's go ahead and change our interdigit timeout. Telephony service. Sorry, it is timeouts. Timeouts, interdigit, and we're going to change it to 7. We were instructed to. Now also, there is a voice register global, and the same thing. Timeouts, interdigit, 7. Also, there is the fact that we need to provide secondary dial tone from the voice register global. And I have to, let's just look here at a question mark to see what options we have. I believe this one is called PSTN. Actually, slips my mind here what the command is for secondary dial tone. It might be that there is no secondary dial tone on our SIP phones. Thought there was, though, and for some reason it's slipping my mind. So, no logo load, external ring, that would be for incoming calls. Okay, well, if I find it, I'll bring it back up, but for some reason it's slipping my mind if there's a secondary dial tone that works for our SIP phones. Okay, do show run pipe to begin with not ePhone, but rather dial-peer. So we've got our timeout interdigits. Let's try a redial again, see if we can count to 7, see if it will work properly. So, whoops, 0, 0, 0, 1, 206, 501, 5111, 1000, 2, 3, 4, 5, 6, 7. There we go. Our interdigit timeout works for our skinny phones. Let's try it on our SIP phones. Last digit, 2, 3, 4, 5, 6, 7. And I'm not actually even sure that our SIP phones are going to fully work properly. Yeah, they're not dialing at all. They're not really registered. They keep going back and forth, and I'm fairly certain it's because of an IP conflict, because we only saw 3 IPs there, and when I was going into the display it kept shutting me down, but I'm pretty sure they're sharing an IP, and so they keep coming back on board and then off. So I'm going to have to reset those SIP phones on the break. But as soon as we're done resetting the phones, we will show that all 4 have IP addresses, and then they can all call properly as well. Yeah, it just went to a restarting state. So let's see if there was anything else in the task. Oh, ensure that all calls made to international numbers have to wait 7 seconds, and they have the option of pressing the hash key. All right, well, let's test this from our skinny phone. Our display here. Okay, so we'll dial 0, 0, 0, 1, 2, 0, 6, 5, 0, 1, 5, 1, 1, 1, and my whole display isn't, and let's dial hash. I dialed hash, you can see, or pound or octathorpe, and nothing's happening. And that's because that was just another digit that the CME doesn't recognize, and it was waiting for interdigit timeout. So it was 7 seconds after I dialed that hash that it looked for a destination pattern that had the hash in it to see if it matched. Now you might say, wait a minute, Mark, I've done a lot of CME installs or iOS installs in general, and if you dial a hash or a pound, it will automatically recognize that as a interdigit timeout, termination. Well, that is true. It will. So let's just end this. Show run, pipe to begin, dial dash peer. See what we have here. We've got our dial peers. Oh, look at this. Dial peer terminator asterisk. That's interesting. Let's highlight this because we're going to clear off our config and do a show run pipe to include terminator. And we see that there's been a dial peer terminator that has already been configured for you. Here in this configuration, we've got some pre-config. Dial peer terminator asterisk. We're going to change that to dial peer terminator hash. And let's just say, after this, do show run pipe to include terminator. And guess what? Nothing shows up because that is the default. So again, if you're used to it working by default, that's great. It normally does. It might not be that way in your lab. Let's go ahead and write our router config before we do anything else. And we'll try this config again, or the test again. So 000, 1, 206, 501, 5111, hash, and immediately it gets rid of the hash that was previously showing and dialed and sends the call out to PSTN, and of course does not have the hash in it. Before, it didn't even send the call out because we didn't have a destination pattern that matched with a hash at the end. Now, show run pipe to section voice 5, I believe was the dial peer. If we had a hash at the end of that terminator, or if we had another dial peer that didn't have a $sign at the end, then it possibly would have matched and tried to send it out. So we have taken care of all of this, and I don't think there's any that goes on to the next page.